Good morning, dear students. So far in arithmetic progressions, we have done till question number 10 of exercise 5.2. Today also we are going to take that exercise only. Those who have not done till here, you can just watch the previous video given in the description. So we'll start. Question number 11. Which term of the AP is given, will be 132 more than its 54th term? So which term means we'll have to find the position of the term, that n we have to find. So to find that, let us assume that nth term is 132 more than the 54th term of the given AP. So we'll take, let an term is 132 more than 54th term, that is A54 of given AP. You can first write the AP in the beginning. Okay, so AN, we have assumed that it is 54, means 132 more than the 54th term. So what is A over here? From the given AP we can write the first term, that is A1, or simple A you can write this is 3. What is D? That is common difference, 15 minus 3, 12. And now we'll just use the formula of nth term. A54 can be written as A plus n minus 1 D plus 132. So A1, that is 3, n is 54 because an is 54 minus 1 into D. D is 12 plus 132. So this is giving us 53 into 12 plus 132. 3 plus 12, 3 is 36, 12 5 is 60, 63 plus 132. So 639 plus 132 is giving us 771. So this is the nth term and we need to find the position of this term. So again we'll apply the nth term formula, A plus n minus 1 D. So directly I am writing A is 3, n we have to find, D is 12 is equals to 771. So n minus 1 into 12 will transpose this 3. So we'll get 768. So 9 minus n minus 1 is equals to 768 upon 12. That is 12 6 and then 12 4. So n minus 1 is equals to 64. That is n is equals to 64 plus 1, 65. Therefore, which term is that? 65th term is the required answer, or is the required term you can write. Question number 12 is, two APs have the same common difference. There are two APs and they have the same common difference. The difference between their 100th terms is 100. So we have to find the difference between their 1000th term. So since there are two APs, we'll have to consider the first term of the two APs, and since the common difference is same, we can assume any one variable for that. So let us take, let the first term, because you know for any AP we need at least two things, that is the first term and the common difference. Let the first term of first AP be, I am taking A1, you can just A, and the common difference is D, and the common difference be D only. So what will be the 100th term? That will be A100 is equals to A plus n minus 1, that is 100 minus 1 into D. So we can write this as A plus 99D. This is the 100th term of the first AP. Fine. Also, let the first term of second AP B, I am taking this as B, and the common difference is same only, so we'll take the same variable as D. So the 100th term of this AP will be B100. It will be denoted by B100, and again the formula is the first term plus n minus 1 into D, so B plus 99D. This is the 100th term of the second AP. Now it is given that the difference between their 100th term is 100. So we will write A100 minus B100 is 100. We'll just substitute the values. A plus 99D minus, now since minus is there, so we'll have to put the bracket, B plus 99D is equals to 100. So A plus 99D minus B minus 99D is equals to 100. So this is giving us A minus B is equals to 100. It means the difference between their first terms is also 100. Now we have to find the difference between their 1000th term. So we'll write A1000 and B1000 will be the 1000th term of the second AP. This we need to find. So we'll just substitute the value. That is the formula. A plus n minus 1. This is going to give us 1000 minus 1. I'm directly writing over here. 999A. This is A. 999D. And this is going to give me B plus 999D. A plus B minus B minus, this is getting cancelled, and we are again left with A minus B, and this is what? This is 100 from equation 1 you can write over here, and therefore we got, you can write over here that the difference between their 1000th term is also 100 only. Question number 13 is, how many 3-digit numbers are divisible by 7? So we'll have to take the first 3-digit number and we'll have to go till last 3, the greatest 3-digit number. So first 3-digit number, it will take, that is 100, and the greatest 3-digit number is 999. But we need to see which are divisible by 7. So this we can do either by the hit and trial method, that you will just start dividing each and every number and you will see whether it is getting divided or not, completely divisible by 7 or not. So as you can see here, this is not completely divisible. So this cannot be my first term of the given list of numbers. So you will keep on trying and you will find that 105 is the first number which is getting divisible by 7. And since we know that the numbers we have to choose should be divisible by 7, so the next term will be 105 plus 7, that is 112, and so on. You have got first two terms. Now we need the last term. The greatest 3-digit number is 999. So here also we'll have to check that is it completely divisible by 7. So we are seeing that it is also not. Five is the remainder. So finally you will, if you are just doing it by hit and trial, you will get that 994 is the term which will be completely divisible by 7. This is the greatest 3-digit number which is completely divisible by 7. Now this I did by hit and trial. I'll tell you one method which you can apply in any question of such question where you have to find the first term and the last term. See, if I wanted to find the first term which is divisible by 7, that is the 3-digit number I am talking about right now. So as I saw here that it is, I divided 100 and I found that the remainder here is 2. So this is actually the question which we have learned in previous classes, in lower classes, that what is the least number which should be added to 100 so that it is divisible by 7. I am repeating the question. What is the least number to be added to 100 so that it is divisible by 7? So how do we find that number? See, this is the remainder I am getting here. So what we have to do, we'll have to take 7 minus 2. 7 minus 2 is 5. So this 5 should be added to 100 to get the first term which is divisible by 7. In case of 4-digit number, you will be taking 1000 and then you will be finding the remainder, and then 7 minus remainder will give you that term which should be added to the 1000. And now to find the last term, see, last term I took as 999, that is the three digit greatest number. Here, what should be that number which is divisible by 7? This I'll find, this is the question actually, what should be subtracted from 999 so that the resulting number is divisible by 7. So whatever the remainder is, that only we have to subtract. So 999 minus 5 is giving me 994. So we got the AP. Now we have to find the number. How many 3-digit numbers are there? So first term A is 105. Then D is 7. And the last term AN is 994. And we need to find this N. So we'll just apply the formula. AN is equals to A plus N minus 1 D. 994. A1 is 105 plus N we need to find, and 7. So this calculation you can easily do yourself. This is giving us 889 and minus 7 and minus 1 divided by 7, and this is going to give us 7 to 7, 7 to the 14, 7 7 to 49. So N is equals to 127 plus 1, N is equals to 128. So therefore there are 128 terms or numbers which are divisible by 128. Actually you should write 128 3-digit numbers which are divisible by 7. So this concept is very important. Next question is also similar to this question only, so I hope you can easily do that question. Next question number 15. For what values of n are the nth terms of the two APs? The two APs are given and the nth terms are equal. So what we have to find the value of n. Now you can easily do this one because the two APs are given and one condition is given that the nth term of the two APs are equal. So we can just find nth term of the two APs separately and then we can equate them. So first AP is 63, 65, 67. So first term here for this AP is 63. Common difference D is 65 minus 63, that is 2. We can easily find the nth term of this AP. A plus n minus 1 D. Nth term A is 63 plus n minus 1. N we don't know. We'll just keep it like this. N minus 1 into D. I have kept it like this only. Now the second AP is 3, 10, 17 and so on. So nth term for this AP we'll find, first of all, the first term is 3 and the common difference is 10 minus 3, that is 7. So nth term of this AP will be A plus n minus 1 D. 3 plus n minus 1, 7 into 7. So this is the nth term of the second AP. And now according to the question, these two values are equal only. So 1 is equals to 2 we can write. We can equate the right hand side of both the terms of both the equations. 3 plus n minus 1, 7. So 63 minus 3 plus 2n minus 2 is equals to, I have just multiplied it inside, and 7n minus 7. So 60 plus 2n minus 2, okay, minus 7n is equals to minus 7, and this we can send over there. Minus 5n is equals to this also. This is giving us minus 5 minus 60. N is equals to 13. We got the value of n. Now this is what the question was. We had to find the value of n. So the 13th term of both the APs are equal. Next, question number 16. Here we have to determine the AP when its third term is given that is 16, and the 7th term exceeds the 5th term by 12. So the difference between the 7th term and 5th term is given as 12. Now, when we have to determine the AP, we know that we need to have the first term and the common difference. It means there are two unknowns. So if there are two unknowns, we know that we need to have two equations. So from the given question, we will try to frame two equations, and then by elimination method, or by substitution method, how to solve the two given equations. So first of all, let us just assume that the first term of the AP be A and the common difference be B. Now according to the question, whose third term is 16? That is A3 we are talking about, and when we are writing A3, we can apply the formula A1 plus n minus 1 D. Okay, so from here it is given that the third term is 16. So A1 or A simply A plus 2D. So one equation we are getting from the given information. Now the second information is the 7th term exceeds the 5th term by 12. It means 7th term is greater than the 5th term, or you can take this as the difference between the two terms. A7 minus A5 is equals to 12. Now A7, if we want to write, we can write this as A plus 7 minus 1D minus, since minus is there, we'll have to put the bracket, A plus 5 minus 1D is equals to 12. So we are getting A plus 6D minus A minus 4D is equals to 12. I have solved this also, and I have solved the bracket also. I have opened the bracket also. So we are getting 2D is equals to 12, D is equals to 6. This we will put in equation 1. So this is giving us 16 is equals to A plus 2 into D, that is 12. So A is equals to 16 minus 12, that is A is equals to 4. Therefore, the AP is, the first term is 4. Now the next term will be 4 plus 6, 10. Next term will be 16. Then 16 plus 6, 22, and so on. You can find the AP like this. Next, question number 17. In this we have to find the 20th term from the last term of the given AP. Now in this particular question, when it is such kind of condition they have given, in this we have to consider the last term as the first term, and then accordingly we have to proceed. So let us see how we are going to proceed. Let us consider the last term as the first term. It means now the AP have got reversed. Now according to this, the last term will be 8, 3, 13, 8, 3. And now we have to find A 20th. This we need to find. To find this, first of all, we know that the nth term formula is A20 is equals to A plus n minus 1D. A we are already having A, so we need D. So for D, A is equals to 253. For common difference, we need to take the difference of the two consecutive terms. So common difference is equals to succeeding terms minus preceding terms, that is 8 minus 13. So this is giving us minus 5. Now this is easy. A20 will be A plus 20 minus 1 or n minus 1 D. A is 253 plus n is 20 minus 1, D is minus 5. So 253 plus 9 into minus 5 will give you minus 95, and this is giving us 8, 158. So this is our 20th term from the last term. Therefore, 158 is the 20th term from the last term of given AP. So this is a particular case where you need to consider the last term as the first term. Next, question number 18. The sum of the 4th and 8th terms of an AP is 24 and the sum of the 6th and 10th term is 44. So we need to find the first 3 terms of the AP. Now again, we know that to find the first 3 terms, it means we need to have the first term and the common difference of the AP. Again, we are having 2 unknowns, so to get the value of 2 unknowns, we need to have 2 equations. And from where we will get those 2 equations? From the given information. So I am roughly doing this. You need to do this question yourself. The sum of the 4th and 8th term, it means one equation will be A4 and A8 is equals to 24. And one equation you will frame from the second condition, that is the 6th term and 10th term is equals to 44. So one equation you will get from here and the other from here. You can solve it, solve the 2 equations by any of the method, by substitution or elimination method, and you will be getting the value of A and D. But after getting the value of A and D, you should not forget that you need to find the AP, that is the first 3 terms of AP. So after finding the value of A and D, you will find the first 3 terms of the AP. So please do this question yourself. I hope you can easily do it. Next, question number 19. Subba Rao started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 200 each year. So we have to find in which year did his income reach rupees 7,000. So we can see that here in this case, this is the case of an AP, as in the beginning his salary was 5,000 and he got an increment of rupees 200 each year. So we can just write the AP of Subba Rao's salary. In the beginning he got salary 5,000 in the first year, that is in year 1995. And in the next year he got an increment of 200. That means in 1996 his salary was 5,200. Now we need to find that in which year did his income reach rupees 7,000. So last term of this AP is 7,000. So you can write the list of numbers is forming an AP whose first term A is, we'll just write 5,000. The common difference D is 200 rupees. And the nth term AN is 7,000 rupees. So we need to find this N, that in which year, after how many years his salary will reach to rupees 7,000. So AN is equals to A plus N minus 1 D. Nth term is 7,000. First term is 5,000 plus N we need to find. D is 200. 7,000 minus 5,000 will give us 2,000. N minus 1, this 200 will transpose, and this is giving us N minus 1 is equals to 10, that is 11. And it means after 11 years he will be getting salary 7,000. So we can write, therefore his salary will reach rupees 7,000 in year. Which year? In 1995 the salary was 5,000. So in year 2006 he will be getting 7,000 rupees as a salary. Now next question, 28th question, the last exercise of this question is the similar type where you will be getting an AP, and again in that question you will be doing the same things. So I hope you can do easily. So with this we have finished this exercise. Please complete your work till here and do all the remaining questions. In the next video we will study how to find the sum of n terms of an AP. Till then just do your work.